G'day folks. So me again. I've got a back catalogue of videos, and in some of those I go through building a battery, right? Specifically for e-skate. And I didn't want to do that again and bore a whole bunch of people, but rather show you the deconstructed view of the battery, the different components, and give you the links to where I buy some of these components. So if you're going down a battery build yourselves for an undermount enclosure deck or a mountain board deck, you know the components where I use and the vendors that I go to buy the various items. So cells, Moly Cell, P42A, vape traders, they are the go-to if you're in Australia. And insulation, barley paper and gasket rings, Renegade E-skate, I use their local up in Queensland, and I also get the nickel strip from them as well, which is the 1.5 millimeter thick 50 by 50 strip as well. So they're key components, and they're hot glued in with a hot glue gun, so they're nice and sealed. Right, 12S6P, P42A. Yeah, the nickel strip, also I have a template that I use, and so zoom in so you can see how close they get to the edges based on the template that I've created. Some vendors sell the nickel pre-cut, but it's always a challenge because you might be doing double stack offset, you might have an enclosure double stack straight up. It all varies, right? So I'm always cautious that if you buy it pre-cut, are you going to use that pre-cut, or is it just worth spending an extra 30 minutes and just cutting it yourself? And that's what I find works for me. Because this is an E-boosted enclosure, the gaskets run fairly thin. So rather than using AWG cable, I use the braided stuff, right? And I get this from Marsden. He's out in WA, sells a whole bunch of other e-skate components as well. So depending on where I'm putting my order in, I'd buy stuff from either vendor. So this is and the reason why I use the braids is because when the tabs of the nickel are folded back, it sits much lower than the AWG cable. So you save maybe about 4 to 5 mil. And I know it's small, but it makes a big difference overall, right? So I use the braided stuff across the top there. The other thing that Marsden sell is the insulation as well. This is the heat shrink. So once the pack is built, depending on the size, each section will be heat shrinked to compress it all in and give it some sealing properties as well. So batteries, enclosure. So this is an undermount enclosure that's going to go on a flow state build, right? So with the enclosure, a lot of folks tend to go down the path of the nightmare of doing a panel mount design where they plug in, the MR60 connectors for the phase motor wires, and having to resolder all the phase motor wires and put 6-pin connectors for each motor sensor. It's a lot of work and with little reward, right? And in speaking to the flow state guys, we just wanted a nice clean system that anybody can get and still have that flush mount panel component added in, but not have to worry about routing and resoldering a whole bunch of cables. Just route them on the inside of the board and plug them straight in. It's going to save you a lot of time. And radial motors now come shipped with 5.5 millimeter bullet connectors, so they can plug straight into your Maker X ESC. There's no resoldering of those phase wires, right? So that's pretty cool. I'm going to do a zoom in on this. The materials that I use, so this is a 3D printed end gasket, and these M4 button head screws are actually from an MBS wheel. I get a lot of these left over from the rear wheels where I install the motor pulleys from. So I reuse these screws and they go, it holds that connector in place. So I'm going to zoom in and show you what it looks like, because this is a two-piece design. Now you've got the back panel mount, which is the first piece, and there's 3 screws, 1, 2, 3. And the reason why there's 3 screws is because this comes out. And the reason why that comes out is so that you can feed all your cables in like that. And then once they're fed in, you can seal that back up again just by sliding that in. It's got a rail that it goes into, and there'll be a 3rd screw that goes in through there that locks that all in place and stops it from moving. And on the underside, you can use some 2-part epoxy to seal that in. Or you actually don't, if you're really adventurous, don't use anything to seal it in. On the opposite side, what you'll find is that it's a 2-piece design. So you've got the actual same, it's the same mount that's sitting on the inside, but going the opposite direction. And then on the opposite side, you have the nuts, right? You have nylon lock nuts to torque it down. And once that's torqued down, it locks in place. It's not going anywhere. So it's it's great from a waterproof perspective, and it seals the deck right up. So this is, I guess, if you're going to look at the 2 components, what they would look like. That's it there. So you've got your deck that sits in there, and these 2 sit side by side. So they squish in to form a cube, I guess. And yeah, so that, and 2-piece design. Nice, simple. It makes, it enables you to avoid having to go down that complicated resoldering panel mount path and just have a simple solution for your undermount enclosure. Yeah, so it's pretty cool. It's 3D printed as well. Right. If you are going to build a flow state deck and you do want those components, just reach out to myself or the flow state team. We can print them off and supply them. So another part of the battery build is the power connector. So this is a 2-pin power connector. It's nothing special. I'm not going to try pronounce the name of this guy, but what I do is I have some clear heat shrink, and I have an XT60 on the end there, and that unplugs. That will be drilled, this component, onto the side of the deck to enable the user just to plug in and charge. There's a little rubber nibbit that, you know, for whatever reason, always tends to disconnect and float off into the ether, but it's held on tightly. So the reason why I have an XT60 connector there is because the chargers I use are these guys, WATE. Again, there'll be links to all this stuff. These are great little chargers. They are 6 amp chargers. And I'm going to take it out of the package. I like them because they are, not only do, whoops, I fuse the battery, but I like these chargers because the charger itself is also fused. So let's take a quick look at what I mean by that. So when you look at the charger, there's a protective fuse here, and there's a glass fuse that sits in there. I'll show you what that looks like. So these are the charges. That's the charge specific. So 12S, 50.4V, and that is a female XT60, right? So what that means is that if you have multiple 12S builds with multiple charge connectors, you can interchange your charge connectors, right? So that's one of the reasons why I like this setup. So, you know, if you've got an Evolve or I don't know, something else that is 12S and is capable of handling 6 amps, then yeah, you can have all your boards You can resolder all your connectors and have them going through here. Word of warning though, when I solder these, I put the positive on position 1 and the negative on position 2. So just because, so if you've got another board with a similar style connector, make sure that it's wired up using that same sequence. Otherwise you're gonna fizz bang your board, right? So that's the glass fuse that sits in that little screw in there, and that comes with a spare in the pack. Now I've unwrapped it, I've got to wrap it back up again. So these are great, they're really cost effective, and whenever I do a battery build, I just quote for the price of material straight up. It just makes it easier for me, and full disclosure to folks that are getting the battery built for them, right? Don't need that. The next component is the BMS. So these BMSs are the, I want to say, new latest fashion in BMSs. They're not the LLT. These ones, I don't know, I'm not going to try to pronounce the brand of it, but there'll be a link to it anyway. These are capable of, I think, running up to 17S. I think from 7 to 17S, if I'm right. No, they're capable of up to 17S, so they do run 12S, which is perfect. But the reason why I like these is because they have an integrated Bluetooth, unlike the LLT that has that separate dongle, so you get extra wires floating around your enclosure. And they're much smaller as well, so they're pretty cool, and they've been working really well for me as well. So that's the BMS. Take a closer look at it. And it's capable of 20 amp, right? They're pretty good. I've built quite a few batteries with these in there, and they've all been working perfectly. So we've got the battery, we've got the charger, we've got the BMS, we've got the charge port. We have the heat shrink. Now, Maker X DV6S, it's a staple in all the builds, and we all know where to get that from, right? And that's really it. So boom, boom, boom. It's time for assembly, time for some soldering, and you're going to see photos of it as the build goes on. So I hope that little insight as to all the little bits and components that I use that go into building the complete battery, where I get those components from, the different local and overseas vendors. I'll be putting links to them in the description of this video as well. So if you want to torture yourself and go down this path, by all means do it. It's a great experience. It will be challenging, but it's fun and rewarding at the same time. So anyhow, keep enjoying this build and my upcoming builds. We'll speak soon. Cheers, bye.